Alright guys, so this is a video to summarize the characteristics of functions. And really all of that is like what you see listed over here. So increasing, decreasing, maxes and mins, bounded, domain and range. And so I drew a graph here, and just to see, we'll start with increasing, decreasing. So when I'm doing increasing, decreasing, as you always read this from left to right. So here I can see the graphs going up. So here it is increasing. Now, when I write these, you're only using x values. So go ahead and just, if you want to make a note of this, only the x values. And so, oops, I forgot to put a parenthesis there. So starting here at the x value of -3 is when I start going up, and I stop right here at -1. Okay, now I start to see the graph move down. So here it's decreasing, so starting from -1 and till I get to the x value here of 1, it's decreasing. And once I get here, again, the graph starts going up, so this is increasing. So I'm going to have another interval here where I start at 1, and remember, the arrow means it keeps going on forever, both in the y direction here and also in the x. But since I'm only concerned with the x values, I can see this is moving towards the positive infinity. Okay, so the positive direction in the x direction. Extremas. So extremas, guys, remember, another word for extremas is just the max and mins. And so I can see here I have a bunch of maxes and mins. Right here, this is a max. Okay. Now, the kind of max I'm talking about here is, you have to ask yourself, is this the highest point of the entire graph? And well, here I can see it's high, but it's not the highest of the whole graph. I still see that it keeps moving up. So this right here would just be called a local, or the way I wrote it over here, relative max. So do I have one? Yes, I do, and it happens at -1, 4. Okay. Here again, I can see that I have a min. And is it the lowest point of the entire graph? Well, no, it is not. So this one here would be a local min, or relative min. So I have one at 1, 1. So absolute max, as you see how this keeps going up forever and ever, so I will not have an absolute max. And down here, I do have another min. However, this is the lowest point of the whole graph, since it's not going lower than this. So this right here would be a local min. Excuse me, not a local min, an absolute min. So that happens at -3, -1. Okay. Next thing is bounded. So you have to ask yourself, do you have any high points? Do you have any low points? Well, on this one here, I can see that I have a low point. And so I do not get lower than this point right here. That's the lowest I go. So this line is happening below the graph. So this is bounded below. And just to give you a couple of examples, something like this, where I have a high point, this would be bounded above, if it kept going down this way. And maybe something that looks like this, where I'm dealing with asymptotes, this would be bounded above and below. So that's what that would look like. So now domains and ranges, guys, remember these are the x values, the y values for the range. So if I'm looking solely at x values, so here, this is where it starts. So here at -3 is my smallest x value. That's where it starts. And I can see that it will keep going on to infinity. Okay. Now, speaking about the y's, the lowest y value that I see is this one right here, starting at -1, and I can see that it keeps going up and up and up, so all the way up to, in this case, positive infinity. Okay, and the other thing, I don't want to use this graph that we've been working with for even and odd, but when I am symmetrical about the y-axis, like I am here, so it looks the same on both sides of the y-axis, this is even. Okay, this one is when I am symmetrical about the origin, so actually the origin is like right here, but really what I want you to check is, look at this graph. It looks like this right now, and if I turn it over, it still looks the same. Okay, so this is the same graph. That makes this one odd. Okay, so that is characteristics of functions, guys. So go ahead and use this to study, and we will see each other in the classroom.